All right, what's up, guys? Today we are doing our lesson 4, all right? And it's just part 2 of lesson 3, basically, okay? So we're just going to interpret graphs of functions, finding values and characteristics of functions from a graph, all right? So the first part, we're going to be comparing two functions to each other, all right? So it says, which variable, x or y, do the function notations of f of x and g of x represent, okay? Now remember what we talked about, our x and y values, okay? Our x is our inputs and our y is our output, all right? And all of our functions are our output, and then x is just our input, okay? And so what we could say is f of x and g of x are equal to each other because they both are y, okay? They both are y. Now, you could have a specific y for these functions, and if you're given a specific y, then we could just find our x. But 9 times out of 10, we'll be given a x value for the function, and we would have to determine what our y is, okay? So, if f of x is equal to g of x, what must be graphically true, all right? So if we're looking at a graph and when f of x is equal to g of x, okay, so f of x is equal to g of x, their graphs intersect, okay, they intersect. I'm gonna zoom in a little bit so we're not writing as small, all right? And if f of x is greater than g of x, what must be true? So f of x is above g of x, okay, talking about our y values, okay? F of x is above g of x. And if f of x is less than g of x, what must be graphically true? F of x is below g of x, okay? F of x is below g of x. Now, here we're looking at our two functions down here in the boxes, all right? It says f of x and g of x can be compared on the interval what? Because that is the interval of the values where both graphs exist simultaneously, all right? Now, let's see, g of x is the solid line and f of x is the dashed line. All right, and the domain for g of x is -5 to 7, but f of x is -4 to 7. So these two functions together can only be compared on the interval -4 to +7, okay? Because f of x lies within g of x when we're looking at the functions graphically, okay? So like I said, f of x is the dashed line and g of x is the solid line, all right? It says use a marker or color pencil and trace the graph from left to right for any values or intervals on which the graph f of x equal to g of x, f of x is greater than g of x, and f of x is less than g of x, all right? So first thing that I'm going to do is I'm just going to identify the intervals or points where whatever it's asking, okay? And then we will go and identify the points in the intervals, okay? So when f of x is equal to g of x, the graphs intersect, right? We learned that in the top part. So they intersect at two specific points, right here and right here, all right? Now, when f of x is greater than g of x, okay, we're talking about our x values, not our x values, but our y values being above, right? So what two intervals in f of x greater than g of x do we have? Well, our first one's right here, and then our second one is here, all right? And then when f of x is less than g of x, okay, will be below, f of x is below g of x. So we are here. All right. Now let's go in and determine our intervals. When identify the x values for the highlighted portion of the graph. Okay, when f of x is equal to g of x is -2 and 5. All right, x is -2 and 5. All right. When f of x is greater than g of x, we have open parentheses because we have a hole right here. So it's -4 to -2 and 5 to 7. All right. Here we have a bracket because 7 is a point. And then underneath, when f of x is less than g of x, we have -2, 5. Or you can write it as -2 is, or x is bounded between -2 and +5. All right, and then it asks if our intervals should be open or close intervals. Give a reason of your choice, okay? So here, we have a mixture of both, okay? And it depends on what the interval is describing and the behavior of the graph at those endpoints, okay? And we beat that that nail with a hammer, okay? Specifically talking about the endpoints, whether it's a hole or a point, you know, open, close, we will have a mixture like we do in this function. Okay? So next thing that we're going to do is we're going to identify the domain of the graph function for f of x and g of x, okay? So f of x is -4, 7, okay? -4 is open because there is a hole, all right? And then the range of f of x is -2, 6, okay? And then the domain of g of x is -5, +7, and the range is -4, +4, okay? All right, so here, excuse me. Here it says that f of x is the dashed line, so I'm just gonna write f of x, f of x, f of x. And the solid line is g of x, so g of x and g of x, okay? For each indicated quantity, write in words what you are asked to find, then find the values or intervals of the values indicating using the graph, okay? So the first one says the values of f of x such that f of x is equal to 0. So if f of x is equal to 0, okay, then the graph is on the x-axis, okay? And x is equal to 1. And if you look right here where this arrow is, you kind of could tell, but if you keep going, it'll cross when x is 15. But we don't have to put that because it's kind of, you know, it's kind of hard to tell. So I'm not even going to, you know, make you guys do that, okay? But clearly it crosses when x is equal to 1, all right? So the second one says the values of f of x such that g of x is equal to 0. So if g of x is equal to 0, then the graph is on the x-axis, okay? And here we have 3 points. We have it looks like at -4.5, at 6, and about 10.5, okay? So at these 3 points, -4.5, 6, and 10.5, all right? And then the values of f of x such that f of x is equal to g of x, okay? So if f of x is equal to g of x, then the graphs of both f of x and g of x, okay, will intersect, okay, and they intersect at 2 points. We'll say it looks like it's approximately negative 0.25 right here at this intersection here. Okay, it's not quite half, so we'll call it negative 0.25. And right here, when x is 9, all right? All right, when the values of f of x such that f of x is less, okay, f of x is less than g of x. So if f of x is less than g of x, okay, then f of x is below the graph of g of x, okay? And you could pause and look up at the graph if you'd like, but here, since we got it cut out, I'm just going to tell you, okay? It's over 2 intervals, and it's when we have negative 1.25 to 9 and 9 to 11, all right? 11 has a close bracket because our graph ends when x is 11, okay? When x is 11. The values of x such that f of x is greater than g of x. We have f of x is greater than g of x. Well, f of x is above the graph of g of x, okay? And it's over the interval negative 9 to negative 0.25, all right? Or you could say x is bounded between negative 9 and negative 0.25. All right, if f of x, or the values of f of x such that f of x is greater than 0, so if f of x is greater than 0, then the graph is obviously above the x-axis, all right? And it's over 2 intervals, negative 9 to 1 and 15 to infinity, all right? The values of f of x such that g of x is increasing. So if it's increasing, then the graph is rising from left to right, all right? And it's from negative 6 to 3 and 9 to 11, all right? When g of x is decreasing, the graph is falling from left to right, and it's over 1 interval, 3 to 9, or you could say x is bounded between 3 and 9, okay? And if g of x is constant, the graph is horizontal, okay? And that actually does happen at an interval negative 11 to negative 6, or you could say x is bounded between negative 11 and negative 6, okay? So the values of x such that f of x is increasing, all right? And so it's increasing right here on this interval, and it's from 3 to infinity, okay? When f of x is decreasing, well, here we have 2 intervals, and it's at negative 9, negative 6, and negative 1 to positive 3. And when f of x is constant, okay, we have -6 and -1, or you could say x is bounded between -6 and -1. All right. So the values of x such that f of x is less than 0. So then f of x has to be below the x-axis, okay? And that's at the interval 1 to 15, all right? 1 to 15. I'm here, like I said, 15 you can't see, but if this graph keeps on going, it crosses about 14, 15, all right? So now check this out. So the values of f of x such that f of x times g of x is less than 0, okay? So if f of x times g of x, okay, is less than 0, then the graphs of both functions, okay, so if f of x times g of x is less than 0, the graphs of both will be on opposite sides of the x-axis, okay? And that actually takes place over 3 intervals, and you could go and look, okay, at -9 and -4.5, and 1 to 6, and I'm gonna move it down here, and from real short interval, 10.5 to 11, all right? Now, 11 has a closed bracket because that is where our function g of x ends. All right, and then the values of x such that f of x times g of x is greater than 0. So if f of x times g of x is greater than 0, then the graphs of both will be on the same side, okay, of the x-axis, okay? And that's over 2 intervals, -4.5 to 1 and 6 to 10.5. All right, on this last page, okay, I want you guys to do some independent practice. As you can tell, h of x is a piecewise function, so I'm going to go ahead and give you the equation. So f of x is equal to 2x plus 7, okay, and x is bounded, so x could be less than or equal to -6 or greater than, and then it's less than, okay, it's just less than 3 because of the whole. And then we have negative square root x plus 3 plus 1, okay, and it's -3. Okay, x could be greater than -3 or less than or equal to 1. And then the last one is negative times x minus 3 squared plus 5, okay, and x can be greater than 1 or less than or equal to 5, all right? And then right here, okay, to determine this answer, you have to graph p of x, okay? You have to graph p of x. And then if p of x and h of x are equal, then they will intersect, okay? But graph it, explain it, give me some answers, okay?